Greetings. I'm Ben, and in this video, I'm going to show you how to do a regression analysis in R with more than one independent or predictor variable. A couple of items that we're going to use in this analysis. The first, in the top right-hand quadrant, you'll see the abort to, which is an abortion question. How pleased or upset would you be if the Supreme Court reduced abortion rights? With 1 as extremely pleased and 7 being extremely upset. So I should say in this video, we're going to use the ANES pilot data, which is the American National Election Study survey from the 2020 election. And the pilot data was collected in the spring. It's available to be downloaded if you go to the ANES website, so you can download it and follow along if you'd like. It's a high quality probability sample of people living in the United States. And we will be using it to try to explain why some people like Donald Trump more than other people. So we'll use this abortion question with the idea that people who are more pro-life would like Donald Trump more, and people who are more pro-choice would like Donald Trump less. So how upset would you be if the Supreme Court reduced abortion rights? You'd think that Trump supporters would be extremely pleased, so they would have a 1, and that Trump opponents would be extremely upset, so they would have a 7. We're also going to use this income inequality question, which is right beneath that. Inc1a is the name of the variable in the ANES data set. It says, do you favor, oppose, or neither favor or oppose the government trying to reduce the difference in incomes between the richest and poorest households? Where 1 is favor a great deal, meaning you want the government to reduce income inequality, and 7 means oppose a great deal. So 1 would be the conservative position and 7 would be the liberal position. And then to the left of me, you'll see this racial resentment scale, which has gotten a lot of traction in political science research recently. You'll see it, like Michael Tesler has published a lot of great work with it, and a lot of scholars have done great things. So what does the scale measure? It's often called racial resentment or racial conservatism. It basically takes the reality that Black people in the United States are worse off than white people in a lot of quality of life indicators that you would look at. So things like wealth, things like income, life expectancy, child mortality, a lot of variables that you would look at, incarceration rates, access to education, and a lot of the things you look like that. It's just objectively the case that it's that Black people in the United States are worse off than white people. And so when you present people with that fact, they are likely to respond in one of 2 ways. One is to say, you know, this makes sense because there's a legacy of racism that is rooted all the way back to the founding of the country, the long arm of slavery, and the way that even after the end of slavery and Reconstruction, we've still been battling the demons of racism constantly in America. So of course, it's going to be harder to be Black in the United States. And all of these unequal outcomes are evidence of those extra barriers and the legacy and perseverance of racism in the United States. Other people look at that information and say, actually, I think that it is just the case that white people work harder than Black people, or white people are smarter or superior in some way. And so basically white supremacy. It's not racism. And so that position is, it's basically a racist position. It's basically saying the reason that Black people are worse off is because they're inferior to white people. And so the way but you can't just ask people, are you racist? Because almost all of them say no. And so we ask these questions instead. And the 4 questions are: Irish, Italians, Jewish, and many other minorities overcame prejudice and worked their way up. Blacks should do the same without any special favors. Generations of slavery and discrimination have created conditions that make it difficult for Blacks to work their way out of the lower class. And of course, this item needs to be reverse coded because high score means that you're low in racial resentment, and a low score means you're high in racial resentment. Then we have, over the past few years, Blacks have gotten less than they deserve. For the same reason, that item needs to be reverse coded. And then we have, it's really a matter of some people not trying hard enough. If Blacks would only try harder, they could be just as well off as whites. And so that is the racial resentment or racial conservatism or modern racism scale. or whatever you call it. So we'll be looking at those as well as some classic sociodemographic variables to see if we can explain variance in evaluations of Donald Trump on the traditional feeling thermometer. Okay, and where do we want to be? This isn't. Let's just start a new R script. Okay, so let's start by getting a table for our outcome variable just so that we can look at the distribution of it. So, and I already transformed this a little bit. I think it's named something else in the original ANES data, but I dealt with the missing values, which I think are coded as 999, and then renamed it DTFT for Donald Trump feeling thermometer because that's the naming convention I'm familiar and comfortable with. So here I just called a table in the ANES pilot data. This is also the name I gave to the data file. And then, this is the variable that I'm looking for. And the $ just says, link this data file to this variable in generating the table command. And you'll see that the top row here is the first set of response options in the feeling thermometer. 915 people gave Donald Trump a 0 on the feeling thermometer. And then, 63 people gave him a 1, 27 people gave him a 2. And then this third row is the next set of response options. So from 17 to 44. Remember, this is a 0 to 100 feeling thermometer scale. So there are 100 response options, though not all of them are selected. And the second to last row is the kind of last set of response options. So you can see 345 people gave Donald Trump a 100. You see, if you look at the midpoint 50, there's 171 people that gave Donald Trump a 50. Now, we also have an age variable in here, so we can just kind of test the theory that, maybe the reason there's variance in how people feel about Donald Trump is because young people don't like him and older people do. So we can test that hypothesis. Let's call this model 1, and this is a basic linear model where Donald Trump feeling thermometer is the outcome. And this little tilde is how we connect, say, okay, have that outcome predicted by, and we're going to say age data equals ANES P. So this is a, kind of review of a simple two-variable regression or bivariate, but this is the outcome. That tilde is how you say the outcome will be explained by, and then this is the one variable we're using so far, age. And then we put that little comma and say, the data set that I want you to use for this is ANES pilot data. So we run that. And remember, when you run a regression model, it doesn't give you an output, it just runs. You have to ask for the summary of your output. And so we'll ask for a summary of model 1. And M1 is just what I called it. Remember, that's arbitrary. You could name it Ben after me if you'd like, because I showed you this. Okay, so let's see what we get in our output. Let's go straight to, the intercept suggests that, okay, I would predict that somebody who is 0 years old would give Donald Trump a 31.68. Obviously, nobody in the data set is 0, and it doesn't make sense to say, infants would give Donald Trump basically a 32, because infants don't have opinions about Donald Trump. But for building the regression model, that's what we would say, okay, when X is 0, Y would be 32. And then the coefficient for age is just 0.21. Notice it is statistically significant if you look at the p-value here. That, E-07 would mean you move this decimal over 7 spots, and so it would be 0.000000135 would be the p-value. So it is statistically significant, but the effect is really small, right? This says for every 1 unit increase in age, and age here is measured in years, so for every 1 year somebody gets older, their evaluation of Donald Trump would go up 0.2 points. So for every 5 years somebody gets older, their evaluation of Trump would go up a point. For every 10 years, their evaluation goes up 2 points. If we really want to see like a 20-point effect, that's like 100 years. And, we're not really going to live long enough for that to be meaningful. Now, we can also see the relatively trivial nature of the effect expressed here in the R square of the output. So this tells us what proportion of variance is explained by this. And you can convert it to a percent just by moving the decimal over 2 spots here. So it's 0.8 or about 0.9%. So almost 1% of variance in how people feel about Donald Trump is explained by age. So it is fair to say that, this is a positive coefficient. As age goes up, so does evaluation of Donald Trump. So it is fair to say that old people like Donald Trump more than young people. But it's a very trivial effect. And if you think that, that theory that just Trump is for olds and not for youngs, that's a pretty weak theory. It doesn't really tell us much about why some people like Donald Trump and others don't. So let's see if we can explain more. And if we look at the names, ANESP, we'll see that I've created a dummy variable for male that we can use here. And we also have a dummy variable already created in the data set for white. And so we can see if it's actually white men that are more likely to like Donald Trump better. Now, why male? If we look, the way ANES measures it, table ANESP sex. So they measure biological sex, and they measure it on a binary. So actually about 1 to 2% of people at birth have reproductive biology or genetics that don't fit within a male-female binary, but the vast majority of those people have doctors assign them either male or female at birth. And so sex is really an assigned by doctor variable. Still, I guess I was, to be honest, I was expecting ANES to measure gender and to measure it with a more complicated and interesting variable, but they measured it with sex, and they measured it as a binary, and we can use that to create a variable where a presence-absence variable, could not find that function because that's not how you spell the word table. Now everybody who's a male, which there's 1,473 people who are males, and so everybody who's a male gets a 1, and the 1,607 people who are identified as female get a 0, and this presence-absence variable will allow us to estimate the effect of being male on evaluations of Donald Trump. Same thing for this dummy variable for white. There are 2,161 people in the data set who are white and 919 who are not. Now, we could do this otherwise. We could get a dummy variable for people who are Black and people who are Latinx and people who are Asian American. And I think definitely in the ANES time series data, you can even get a lot more granular race and ethnicity codes, much more specific than just Asian or Latinx. And so you can do more interesting stuff with that. But for now, we'll just test the old, white men like Donald Trump theory. Older white men, right? So this is what we're here for. How do you include more than one predictor variable in the model? So we will do age still. And now to add a new variable, we just do plus male. How easy is that? Right? It's like, okay, how do I add more variables? Just plus and then the name of the variable. Then we'll do plus white. So now we have 3 variables in the model. Data equals ANESP. And then we'll go summary, M2. Now you'll see that up here, age is no longer statistically significant, but male is statistically significant. And you'll see that being male is worth about 6 points for Donald Trump. So another way of saying that is that men like Donald Trump about 6 points more than women, because this is for every 1 unit increase in male. And the units are only 0 female and 1 male. So a 1 unit increase just means being male. So being male is worth 6 points. Being white for Donald Trump is worth 20 points. So compared to non-white people, white people like Donald Trump 20 points more. And that's, quite a bit compared to this, paltry effect of age. And again, this is a presence-absence variable. So if you took the average feeling thermometer score for everybody who's not white and the average feeling thermometer score for everybody who is white, the white people's average would be 20 points higher than the non-white people's average. And notice both male and white are statistically significant predictors. This is interpreted to mean that after accounting for the role of age and sex, being white is worth 20 points on the feeling thermometer scale. So the coefficient is interpreted as the effect when holding the other variables constant. And when we look at the adjusted R-square, we're now explaining almost, not quite, 7% of variance, which is a lot more than not quite 1%, but is not a very compelling explanation of why some people like Donald Trump and other people don't. Now, I study politics, and so I can tell you, be ready for a genius revelation here, that what we're missing is partisanship. So if we really want to explain why some people like Donald Trump and others don't, we should account for the fact that some people are Republicans and other people are Democrats. Brilliant, right? And if you look at the ANES pilot data, they have a variable called PID7. That stands for partisan identification, or party ID. And 7 indicates that there are 7 response options. And so if you look at the code book, 7 is coded strong Democrat. How lucky, 777. What a lucky code right there, right? So 777 people are strong Democrats, 389 people are just regular Democrats, 300 people lean Democrat, 420 people can't be bothered to align with a party, 214 people are lean Republicans, 328 are regular old Republicans, and 649 are strong Republicans. So let's put this party ID variable in our model and run it and see if we can explain more than 7% of variance in evaluations of Donald Trump. So the first thing you'll notice is that these numbers don't look good anymore. And it's because age becomes such a small effect that it wants to give you this E-04 here. And so that just means, to understand the effect, you have to move that decimal, 4 points over. So it would be 0009. And then notice that's plus 00 plus 00. Cool. So that just means those numbers. And then this is plus 1. So that means that you would actually move that over 1. And notice that now we are explaining 48% of variance in evaluations of Donald Trump. And so the model went up from 0.067 to 0.489. So it went up from basically, 7% to 48%. So that's an increase in R-square of 41%, or a 41%, a 0.41 R-square change. That indicates that this is a very powerful variable. So this is a useful way to talk about the value of your theoretical variables. When I add my theoretical variable to the model, the R-square value improves this much. And that improvement in R-square would be indicative of the strength of your theory. So the theory that Republicans like Donald Trump more than Democrats is a pretty strong theory, shocking absolutely nobody. What we really want to know is if we get value by accounting for people's positions on abortion, income inequality, and racial resentment. So do those variables add considerable value to this model? And if so, how? And which ones are more powerful? So we will do a fourth model, LM DTFT. So again, LM is just how you say I want you to fit a linear model. And we're going to still use age, male, white, and PID7. But let's also add, let's see, it was income. Now I'm going to have to look at the names of this to remember there. I think I actually have them in this other window. So let's just see. It's income 1A. I'm just going to copy it. I'm not going to remember those random. I think I was pretty close. And then it was abort 2, I think. Sometimes it autofills and tells you this is the name of it. Yep, abort 2. And then RR. Data equals party, NESP. Before we run this, let me show you a little bit about these 3 variables we're adding. So if we do table NESP income 1A, you'll notice that our response options are 1 through 7. Now, this isn't actually how it shows up in the ANES data. There's another one, there's another number 9 that is the missing values, and I had to transform the missing values here from 9 to 1, indicating that 9 isn't an actual value. If you run it the way ANES gives it to you with a 9 as the code for a missing value, then it will think all of the people who have missing values actually just have really strong opinions on the variable. And so you have to tell R that it's missing. And I'll have another video that shows you how to do data transformations in R in case you want to know how to recode a variable to get rid of the missing codes or to reverse code for the example. So if we do describe NESP RR, you'll see that we have 3,073 responses for the racial resentment variable, that the mean is 3.12, the standard deviation is 1.04, the median is 3, the minimum is 1, and the maximum is 5. Remember, those were the response options. It ranged from 1 strongly disagree to 5 strongly agree or something like that. And I reverse coded the reversed item and created the aggregate. So this is all 4 of those, and it's scored so that higher values is the more racist position and lower values is the less racist position. So we run the model with these 3 new variables, summary, M4, and we see, I guess we can start with the adjusted R square. We see the model we're now explaining more than half of the variance in evaluations of Donald Trump. So by accounting for people's attitudes about income inequality, abortion, and racial resentment, we go from 48%, almost 48.5% to 59%. So, an 11% increase in explaining evaluations of Donald Trump. And I would say that's pretty impressive here because that's above and beyond what can be accounted for by partisanship alone. So we know that some Republicans like Donald Trump more than other Republicans, and some Democrats like Donald Trump more than other Democrats. In other words, there's variance within how people feel toward Donald Trump beyond what can be explained by partisanship alone. How do we explain variance, within partisanship? How do we explain variance between Democrats and how they feel about Donald Trump? How do we explain variance between Republicans and how they feel about Donald Trump? Well, these variables help. And you can see kind of how much they help. For every 1 unit increase in this income inequality question, and remember, 7 represented, the government should stay out of it, and 1 represented the government should try to reduce income inequality. So for every 1 unit increase in that, Donald Trump gets almost another point in the feeling thermometer. And that doesn't look very powerful. It is just statistically significant, right? And when we have 3,000 people in the model, it's going to be really easy to detect even pretty small effects. And this is a pretty small effect. I mean, if you go from the most liberal position at 1 to the most conservative position at 7, you're only increasing feeling thermometer for Donald Trump by about 6 points. Compare that to this abortion where, remember with abortion, 7 was that I would be very mad if abortion rights were restricted, and 1 is I would be very happy if abortion rights were restricted. And so that's worth almost 5 points for Donald Trump. And so if you think going from the most liberal position to the most conservative position, that would actually be worth a pretty substantial change in Donald Trump's feeling thermometer score. And then with the racial resentment, this appears to be the most powerful variable of the lot. Appears to be, but maybe isn't. And I'll tell you, and the reason is because it's on a different metric, right? But we can see that for every 1 unit increase in racial resentment, evaluations of Donald Trump go up about 7 points. And remember, the lowest racial resentment score in the data is 1, and the highest is 5. So moving from 1 to 5 would be worth quite a few points on the racial resentment scale. And we do know that in society, there are people who have, that low score and people who have that high score. But we kind of have a problem if we're trying to say, all right, white, and you see white now is only worth about 5 points rather than, I think it was worth like 20 points earlier. So one thing is like, why did that go from a coefficient of about 20 to a coefficient of about 5? Well, it's because white people are more likely to be Republican. White people are also probably more likely to harbor racial resentment. And so when you account for these, the effect of being white goes down. Another way of thinking about that is you might say the primary reason why white people like Donald Trump more is that they're more likely to be they're more likely to be Republican, they might be more likely to be pro-life, and they're more likely to harbor racial resentment. Now, is that actually the explanation? You can test that. You can basically test that theory with mediation analysis, which I will show you how to do in a different video. So you can look for a video on how to do mediation analysis in R to see how you could test that. Maybe that's the example I'll do for that video. That would be interesting, right? Okay, but if we want to know, okay, it seems like party ID is the most powerful and racial resentment is the second most powerful, and then, being white, and then this abortion question. But the thing is, this is a 1 unit scale. It only goes from 0 to 1. This goes from 1 to 7, so it has a lot more units. This goes from 1 to 5, so it has fewer units. So we're kind of comparing apples to oranges. And this is why some people like to use standardized regression coefficients, which expresses the size of the effect in units of the standard deviation. And in SPSS and in other statistical software packages, the standardized coefficient is automatically provided, but that's not the case in R here by default. So I use the quant-psych package, which you can load. If you install this quant-psych package, you can load it by typing library and then in parentheses quant-psych. Or if you're using RStudio, you can install it by clicking this install button and searching for it, and then finding it in your little environment here and clicking it. So once you have quant-psych loaded and installed, you can do beta.l, I think is it beta.lm and then m4. Let's see if I'm remembering that syntax right. Nope. What is it called? Oh, it's lm.beta. See, I was so close. lm.beta. Then we'll look at model 4. And this gives us the standardized regression coefficients. So they're all on the same unit. And this says, okay, age, really small effect, 0.0001. And we know it's not even statistically significant. The effect of being male, 0.02. The effect of being white, 0.05. Party ID is, negative 0.471. So, 47 in absolute terms, much higher than 0.05. So no surprise, partisanship, much more important than race. Income inequality, only 0.04. So less important than race, more important than sex, but not all that important, especially compared to abortion, where the effect is 0.25. So not as powerful as partisanship, but still we would say, okay, so in addition to the difference between Democrats and Republicans, even above and beyond what can be explained by being a Democrat or being a Republican. This social conservative attitude, and here I'm thinking that abortion stands in for kind of a social conservatism in general, but it might actually just be that abortion's really important to people. So is this abortion, and marriage, equality, and issues about trans rights, are all of these things kind of in the same conglomeration, or does abortion stand head and shoulders above? I'm not sure. I'm kind of thinking of it as a marker for social conservatism. And then you see this racial resentment, it's basically a 0.2. And so not as powerful as this abortion item, but even after accounting for this kind of social conservatism, even after accounting for partisanship, even after accounting for age, sex, race, and economic attitudes, we see that the racial resentment variable is a powerful explanation of variance in evaluations of Donald Trump. So that is how you do a regression analysis with multiple variables, how you can interpret some of the output, and how you can also get these standardized regression coefficients, which most people who use another software package are probably used to getting by default. Remember, to get those, you have to install and load the QuantSight package, and then it's just lm.beta and then your model number, and it'll give you the standardized coefficients. Okay, so I hope that video was useful for you and that you have some fun playing around in R, running some regression models, trying to explain why some people like Donald Trump, or which stock is going to perform well, or what the weather is going to be tomorrow, or who's going to win the next election, or which rookie is going to be better at basketball, or whatever it is you want to model. Thanks for watching to the end. I hope you enjoyed it.